Have you ever wondered how we know what stars are made of, even though they are trillions of miles away? Or how doctors can analyze our blood without even touching it? The answer lies in a fascinating field of science called spectroscopy. Spectroscopy is like a cosmic detective using light to unlock the secrets hidden within matter. Just as a prism separates sunlight into its constituent colors, a spectrum spectroscopy allows us to analyze the interaction of light with matter, revealing its unique composition and properties. From the distant galaxies to the tiniest atoms, spectroscopy has revolutionized our understanding of the universe and our place in it. It is a powerful tool that allows us to see the unseen, understand the unknown, and push the boundaries of scientific discovery. To understand spectroscopy, we need to understand light. Light is a form of electromagnetic radiation, a wave of energy that travels through space. But light is more than just what we see. It exists as a spectrum of wavelengths, from radio waves to gamma rays. Each color of light has a different wavelength. Red light has the longest wavelength, while violet has the shortest. Our eyes are only sensitive to a small portion of this spectrum, which we perceive as colors. When light interacts with matter, it can be absorbed, emitted, or scattered. These interactions depend on the wavelength of light and the properties of the matter it encounters. This is where spectroscopy comes in. Spectroscopy works by analyzing the light that has interacted with matter. When we pass light through a substance, some wavelengths are absorbed by the atoms or molecules within it. This creates a unique pattern of dark lines in the spectrum, called an absorption spectrum. Conversely, when we heat a substance, its atoms or molecules emit light at specific wavelengths, creating a pattern of bright lines called an emission spectrum. These spectra are like fingerprints, unique to each element or molecule. By analyzing these spectra, we can identify the composition of a substance, determine its temperature, density, and even its motion. Spectroscopy is like listening to the whispers of atoms and molecules, deciphering the language of light to reveal the secrets of matter. One of the most remarkable applications of spectroscopy is in astronomy. By analyzing the light from distant stars and galaxies, astronomers can determine their chemical composition, temperature, and even their motion towards or away from us. For example, by observing the redshift or blueshift of spectral lines, astronomers have discovered that the universe is expanding. This groundbreaking discovery revolutionized our understanding of the cosmos and led to the development of the Big Bang theory. Spectroscopy also allows us to study the atmospheres of planets in our solar system and beyond, searching for signs of life and unraveling the mysteries of planetary formation. It is a powerful tool that has transformed astronomy into a more precise and insightful science. Section 5. Chemical Detectives. Spectroscopy in action. Spectroscopy is not just confined to the cosmos, it plays a crucial role in our everyday lives. Chemists use spectroscopy to identify unknown substances, analyze the purity of chemicals, and study chemical reactions. For example, infrared spectroscopy is widely used in forensic science to identify drugs, fibers, and other materials found at crime scenes. It is a powerful tool that helps to solve crimes and bring justice to victims. In environmental science, spectroscopy monitors air and water quality, tracks pollution levels, and studies the effects of climate change. It is an essential tool for protecting our planet and ensuring a sustainable future. Section 6. Seeing the invisible, infrared and beyond. Our eyes can only see a small portion of the electromagnetic spectrum, but spectroscopy allows us to see beyond the visible. Infrared, or IR spectroscopy, for example, detects the heat signatures of objects, revealing information about their temperature and composition. IR spectroscopy is used in night vision goggles, thermal imaging cameras, and even medical diagnostics. It allows us to see in the dark, detect heat loss in buildings, and even diagnose diseases. Other types of spectroscopy, such as ultraviolet or UV, and X-ray spectroscopy, allow us to study the electronic structure of atoms and molecules, leading to advances in materials, science, electronics, and even medicine. Section 7. Molecular Architects NMR Spectroscopy. Nuclear magnetic resonance, or NMR spectroscopy, is another powerful tool that allows scientists to study the structure and dynamics of molecules. NMR exploits the magnetic properties of atomic nuclei to determine the three-dimensional structure of molecules. even in complex mixtures. This technique is widely used in chemistry, biology and medicine to study proteins, DNA, and other biological molecules. It has revolutionized drug discovery, allowing scientists to design and develop new drugs with greater precision and efficacy. NMR is a non-invasive technique, meaning it can be used to study living organisms without harming them. This has led to significant advances in our understanding of biological processes and the development of new medical treatments. Section 8. Light as a scalpel. Spectroscopy in medicine. Spectroscopy is rapidly transforming the field of medicine, offering new ways to diagnose and treat diseases. Medical imaging techniques such as magnetic resonance imaging or MRI and positron emission tomography or PET rely on spectroscopy to visualize internal organs and tissues. Spectroscopy is also being used to develop new non-invasive diagnostic tools for diseases such as cancer, Alzheimer's disease, and diabetes. These tools could lead to earlier diagnosis, more personalized treatments, and better patient outcomes. Furthermore, laser-based spectroscopy is being used in surgery to remove tumors with greater precision, minimizing damage to surrounding tissues. This minimally invasive approach can reduce recovery times and improve patient outcomes. Section 9. A bright future. Spectroscopy in the 21st century. Spectroscopy has come a long way since its inception, but its journey of discovery is far from over. As technology advances, we can expect to see even more innovative applications of spectroscopy in the 21st century. From developing new materials with tailored properties to unraveling the mysteries of the human brain, spectroscopy will continue to play a pivotal role in shaping our understanding of the world around us and driving technological advancements. As we venture into the unknown, spectroscopy will be our guiding light, illuminating the path to new discoveries and a brighter future.